Hey folks, Cool18 here, and welcome to another episode of our Unity 3D multiplayer first-person shooter tutorial. And so in the last episode, we got our motion working in with our new script, our much simpler script than the one that's included in the game, which does mean that we're going to have to do a little bit more work here and there to get certain concepts working, but it also means we can discuss those things, and it means that we can a little bit more fine-tune things to our animation things. So we do not have the ability to move in the air right now, which we may or may not want. We also don't have the ability to jump. And our guy is stuck in permanent running animation mode, which we definitely don't want. So let's go and figure out, first of all, why is he always running? Our animator, oh yeah, because we set our speed parameter, we've started it at 1. Let's go and start it at a 0. That way, by default, so speed is going to be set to 0, so he's going to stay in the idle animation at that point. That's good. So we're going to start with that. Next thing, over here, in our, oh, it doesn't really matter if we do it in our fixed update or in our update, to be honest. So we will set, okay, we have an animator component, animator, call it anim. We will grab it in our start. Anim equals get component animator. Animator, not animation, animator, very different, because we're using the new mechanism thing. So in our update, we are going to set our anim dot set float speed. We're going to set our speed parameter, and we're just going to use direction dot magnitude. I think that's going to be fine. Well, do we actually want it to be normalized? I'm having second thoughts about different things here. And honestly, might be okay that our diagonal movement is better. I don't know. If we're not moving at all, I think even normalized, it should come out to 0. Oh, here's what I want. Okay, the reason I'm getting confuzzled here is, let's say I was playing this with a joystick, right? Like on a keyboard, when you hit forward, it automatically goes to a full 1. There's no way to end up like at half speed, for example, on a keyboard. But if you're using a controller, like if you've got an Xbox 360 controller plugged into your computer, or if you've, ported your game to a console, for example, and you're using a controller or a joystick that's got an analog stick, well, you can move your stick only slightly forward, which means you can sort of walk instead of run, right? And this, by normalizing it, this means that if my direction for some reason would be, say, 0, 0, and 0.1, well, this dot normalized will get normalized to 0, 0, 1. Again, unless I'm making a confuzzlement about how normalized works, this should be how it works, because normalized should always return a vector of length 1, which would be this. So this is not what we want. We actually only want this to happen if our magnitude is above 1. So let's not normalize it here. We're just going to do a thing. If direction dot magnitude is greater than 1, then direction equals direction dot normalized. There we go. I think that may be better. So that way we can have a speed that's technically, between 0 and 1 if need be. Because one thing you can do, and again, I don't want to get into super involved stuff here for mechanism, but we could create a blend tree state here. And we can have a blend tree based on speed, and we can have 2 motions. One is, the first one here could be walk, and the second one could be run. And we can set, and we can have them blend from one to the other. So we could have set thresholds or whatever, however you want to do it. Like, let's say I don't know, that doesn't matter. Automatic thresholds is fine. So when the speed is low, it's going to be mostly doing the walk animation, but as the speed gets bigger, it's going to blend between walk and run, and then as your speed approaches your maximum, it's going to convert entirely into a run motion. Very cool, sexy stuff. We're not going to be doing that in this video. In this tutorial, probably. Maybe I don't know. I don't think we're going to have the animations for it, but conceivably we could, because we do have a run animation, and if I go and check the, this is the mechanism tutorial from Unity, they do have a walk animation, right? Walk forward. They actually have the runs, but they also have the walk. They have the runs. So we could do that very smooth and cool transition, but we're not gonna. All right, so we get a direction, and then we're going to feed that magnitude back in as our speed. So I think if we hit play, move to the scene view, find our character, there he is. So now he's idle, and if I go back in here and hit forward, he'll go into a run. And it's a bit, there's a transition from one to the other, which looks really, really quite nice. Right? He goes slowly at first, and then he moves up. And again, we are going to have that sort of ice skating thing because, well, actually, it's pretty close. Our run motion forward, our forward motion speed is not actually what the animation was designed for. And the other thing that's happening right now is our run, when we're moving backwards, we're still doing the forward running animation, which means we've got this weird moonwalk thing going on. Right? And so what you could do here, instead of feeding in the magnitude, you might want to just feed in, at least before the rotate, like you could just feed in, say, the vertical input, which would mean, because if you're pushing forward, it will go from 0 to +1, but then if you're holding the backwards key, it'll go from 0 to -1, which means that in our animator, right now we're moving to the run animation if our speed is above 0.1, but then we could have a separate animation here called, like, run backwards, and we could have a transition from idle to run backwards when our speed is less than -0.1. So when our speed goes negative, we will start a running backwards animation, right? And then if it goes forward, if it goes positive, then we'll do a run forward animation. And it looks brilliant and awesome. And things that look brilliant and awesome have no place whatsoever in our tutorial. So we're going to use the same run animation no matter what. And this includes if we are strafing or straffing. I don't know. People say it both ways. If we're moving from side to side, then the run animation will look really inappropriate, but who cares? If we're going left and right purely, it's still going to do the same run. But that's okay. Now we still transition from idle to run, and I think that's great. Makes me very happy. All right. So that was the very first thing there. And you can have multiple parameters, right? It's probably you'd probably have one for strafing, left and right. And then you're probably going to have a Boolean or a trigger for jumping. For our situation, again, it doesn't matter. We're just going to use speed for everything. So, kind of irrelevant. Well, actually, that's not true. I actually do want one for jumping. And we'll use a Boolean. The difference between Boolean and trigger, originally when Mechanim came out, there wasn't a trigger option. It was just Boolean. And what's weird is that, so it's true or false, right? So when true, play this animation. But it can get in this really weird situation where it keeps sort of like repeating and looping and stuttering and starting over and over. So what you'd have to do in your script is you'd have to do something really weird like, oh, okay, we're jumping. So set the jumping to true. But then on the next frame, check if we are currently playing the jumping animation, then set jumping to false, because otherwise, because it doesn't reset properly and all kinds of bizarre things. If you use trigger, trigger is basically a Boolean that automatically resets itself to false as soon as the animation starts. Here, actually, we do want Boolean to be jumping, or it's actually going to be, this is mostly going to be, we are currently not touching the ground. So we are going to want to look like we're not currently touching the ground. Actually, we might be able to steal an animation for that. Because they do have the jump, right? And I was complaining that the jump animation, oops, I don't want to put it here. I was complaining the jump animation is not right for what we want to do. And I'll show you why that is. And pull in the jump animation. Again, that's from the Mechanim tutorial. So we're going to take a look at jump over here. And we're going to play it. So he goes into the sidestep roll. Yeah, no, it's really not good for us. Never mind. I was hoping there would be like one frame where he just sort of looked kind of crunched up, but there isn't. Is there another animation that might be appropriate? Well, maybe in the jump down, there might be a frame that we can grab from that. What does the jump down look like? Whoop. Oh yeah, see, he's got one little crouch thing. Oh, this is going to be great. All right, let's change the rig. Avatar, so we want humanoid, and copy it from our soldier. Not that it really matters. But we'll copy it from the soldier. Avatar, and then what we're going to do is just find, we're going to create a new animation, and we're just going to call this sort of the jumping animation, and it's just going to be a frame of, oh, the avatars don't match up properly. His arm is all like crazy pants. That's no good. Fine, create from this model. Is it still gonna be like that? Okay, now it's working fine. There we go. So I just want him to be in like this pose right here. So, oh, this is our jumping. Here, hold on. There, that's pretty good. And it's gonna be like super short, like nothing going on. Just a couple of frames, looping. Might be a little too spazzy. What if I had like nothing? Oh, no, still no good. There, start and end on the same frame. Can you do that? There, okay. I just wanted to sort of freeze in that frame, and that's fine. We'll bake everything in there, not that it really matters terribly much. Apply. There. That's going to be our jumping animation. It's just going to go from idle or from whatever he is straight into this thing. Good. I like it. It's not sophisticated at all, which means it's perfect. So again, there was that actual run and jump animation, which we're not using, and then this jumping thing that I just created, which is just one frame of him hovering in the air. We're going to drop that into our base layer over here, and we're going to create transitions. We're going to go from idle to jumping. So we are going to, if jumping is true, go to jumping, and then whenever jumping becomes false, go back to idle. So when jumping is false, go back to idle. We also want to be able to jump from our run animation, so we have to make a transition from run to jumping. When jumping becomes true, go to jumping. Now, we could create another transition that goes back from jumping to run. And then what you would do is you'd make it slightly different. I'll show you the example. So from jumping to run, so we want to go from jumping to run when jumping becomes false. Then I'm going to hit this little plus. And speed is greater than 0.1. So if jumping is false and speed is greater than 0.1, go to run. But then I'd also have to adjust this one idle here to say, go from jumping to idle when jumping is false and speed is less than 0.1. So that way, when we stop jumping, it'll go from to either idle or run, depending on what our speed is. I guess actually that's probably good. I was doing this as an example, but I guess we'll do this. I was gonna say, because there's something to be said about when it jumps, go to idle first, and then transition to run, you know, so there's sort of like a little bit of a almost visible delay. But the problem is there's not actually going to be a delay in our code. We're going to be, because again, we're using very simple old school first-person shooter physics, where you don't really, you know, pause when you hit the ground. You just keep running at like full pin, because why not, right? Okay, that works just fine. So going back to our code, what is our jump? Well, so right now, our desired direction is this. And then we're going to put in another, and based on our direction, we'll set the speed. So this first area here, this is WASD back, or I should say, forward, back, and left and right movement is stored in direction. Okay, that's one. Then we're going to have handle jumping. So if we are currently grounded, if we are on the ground, and input dot get button jump is pushed, this will return true if we are currently holding jump. Now, there's a difference between get button and get button down. This will only return true on the frame in which the spacebar was hit. So for this version, we would need to tap the spacebar to jump, and then after we've landed, we'd have to hit the spacebar again to jump again. With just get button, we could just hold down the spacebar, and as soon as we finish our jump and we land on the ground again, we would instantly just jump back up. Jump down, jump, 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 non-stop, just constant bunny hops. Which way is better? I don't know. It depends on the game you're making. I guess we'll go, you have to hit the button again. Why not? All right, so if we're on the ground and we're currently, we push down the button, what are we going to do? Well, we're going to go back. So direction, this is just our forward, back, and left, right direction, because we're setting the y component to 0. I'm going to create a separate variable And it's just going to be a float for our vertical velocity. Okay, we're going to start it off as 0. So if we're currently jumping, we're going to set our vertical velocity to be, I don't know, jump speed. We'll set it to 20. I have no idea if that's even remotely. And we got pretty close with the speed, actually. That speed of 10 felt pretty good. Vertical velocity, we're going to set to our jump speed. Okay, that's if we're currently on the ground and we're hitting the button. We're going to set a vertical velocity. If we're on the ground, if we're currently on the ground, I don't know, we'll put that code in somewhere else. So again, we're not being entirely physicsy. We're literally just like our velocity is just getting a huge boost straight up. There's no build up to the jump, right? Because normally in a true physics, or as a human body really moves, if you were doing an animation-based thing, well, your character would sort of have to crouch down first and then spring up into a jump. Here, no, we're just going to take off instantly because, god damn it, that's the way it should work. All right, I'm going to call that good enough. Okay, so in our fixed update, first things first, we're going to move from simple move to move. And as I said before, this move wants an actual distance that we're moving as opposed to a speed. So we have to multiply this by time.delta time. That's a pretty good start. Except it's not quite right because we're not incorporating our vertical movement yet. Or gravity, for example. So I'm going to move this out, actually, here. I'm going to create a new vector 3 called I don't know, call it distance, right? So first we're going to set the distance based on our forward and backwards, left and right movement. So that part is taken care of. The only big question mark is what to do with our vertical velocity. So we're going to put in some code. First of all, well, the way it would normally work, let's get some of it out of the way. So our vertical velocity, every frame is going to be changed based on our gravity, which is in our physics system dot gravity, and this is technically a vector 3, so we're just going to read the y. Maybe we don't want to use a float here, maybe we want to use a vector 3. Listen, it's going to be fine. So actually, it's probably a plus. We're going to add our gravity component to our vertical velocity. This is how it should work every frame, except if we're grounded, if we're on the ground, and this is what I forgot to do in our last tutorial, we actually want to reset the velocity to be 0. Because otherwise what will happen, you're standing on the ground, everything is fine, and the second you step off a ledge, you're going to be going downwards at warp speed because this entire time gravity's been accumulating against you. So first, if I just do this at this point, oh, and then we want to set in our distance that we're going to cover, our distance dot y is going to be equal to our vertical velocity times time.delta time, and then we're going to feed this distance into move. So right now, jumping will not work, but we should be able to fall off a cliff. Let's find out. Okay, we can move around. Everything is groovy. So we should be able to jump off a cliff again. Woof! And we do. It almost felt too fast, but I think it's technically working. I think it's just, turns out gravity is a bitch. Let's wait a sec and see if it feels any faster before I throw myself off. But I think it's just going to be, I think that's actually just how gravity should mostly look. Just fall off instantly. Does it still feel? Yeah, it still feels fast, which is exactly it. Now, maybe our character should be more floaty. In fact, in this map, on this map, being in space, classically, it tended to have low gravity. Now, you can choose to have the characters follow a different gravity system than everything else in the game as well. So it's up to you. If you want to change the actual world gravity, go into Edit, and then go into Project Settings, and then Physics. And in here, you can set the gravity here, which is currently at 9.81 meters per second squared, which is actually what gravity is. But maybe this is supposed to be a low gravity map, so we could scale it down to here. We'll leave the gravity where it's supposed to be, but for our characters, we're going to make our characters slightly more floaty by taking the gravity and just cutting it in half. So now we won't fall down quite as fast. Maybe we have anti-gravity boots or something like that. I don't know. It's still going to be pretty goddamn fast, but... Oh! Hang on. I think that's part of the problem. Well, that's definitely too slow. Let's not cut it in half anymore. And let's give it a second to think here. Oh, no. We had it right. Because we're doing the time.delta time here. Oh no, this distance. No, we do just want to add that. No, we're okay. We don't need to cut it in half anymore, though. There we go. This feels like video game gravity. Oh god, I'm falling. I'm falling faster and faster and faster and falling off the face of the earth. What we can do is actually report on our vertical velocity and just make sure it's looking decent. So debug.log, our vertical velocity should be growing as we fall. It should be 0 when we're on the ground. Anytime we're grounded, it should report 0. And other than that, it should grow. 0, 0, 0. There. There's a slight negative in there from time to time as we're taking our steps. We're not necessarily perfectly aligned to the ground, but it fixes itself quickly. And here, yeah, it does grow. So we're falling faster and faster and faster over time. Okay, we're fine. There might be a math error. I'm not going to guarantee that there isn't, but it's at this point I'm going to call it good enough, and we'll see what we can do later on. So we've got everything in there except the jumping, and technically we do have our jump command in here. The only problem is I think this is going to fire incorrectly. I could move it up here. Right, set it to 0 first, and then if we're jumping, do that. Or I could wrap it differently. If grounded, start a thing here, and then inside of that, check to see if we're jumping. Or I could set a Boolean, to say we are currently jumping. I think the easiest, laziest way is to do the vertical velocity and set it here to 0. Anytime we're grounded, set it to 0, and then check again if grounded and jumping, change it. So, why can't I actually jump? That is the question. I'm hitting the button, nothing is happening. Input get button down jump. I believe that's what the button is called. I think it would whine if there wasn't an input called that. Indeed, there is a jump, and it's set to the space bar. Debug.log. Let's put the vertical velocity back in. I thought the space bar would be working at this point. Oh! Whoa. Okay, that is... Oh, it's just not... I don't think the is grounded check, because it's... Because we even saw sometimes it's not doing the setting it to 0. It's not always seeing that we're actually grounded for some reason. And I don't know why that is. Well, if I set this to just like that, then it should actually be quite a bit more responsive. Yeah. Although our jump is definitely set a little too aggro here, because it's taking... Woo! 20 is too much jump. Set it to 5. I think 5 is going to be too little. It's going to be a barely little bunny hop. But 20 was like rocket boots. There we are. Well, that might be enough. I feel like it should be a little bit more of a jump. Say an 8. That's going to be quite the hop. Let's find ourselves in the game world and then actually take a look at what it looks like from the outside here. Yeah, that's too much. But I think 5 was enough. You know what we're going to do? We're going to set it to 6, and then I think we're going to call it good enough. No sense in playing around with our jump size forever and ever and ever. Find ourselves, bring us over here, jump. I mean, it's obviously unrealistically high, but not necessarily bad. So we're not playing our jump animation. That's the only thing that's going on. So let's get that in right away. So And basically, we want the jump animation to happen actually whenever we're not grounded. Again, I feel like the is grounded is being a little wonky, but let's see what we can do. Let's move some of this code, actually. If we're grounded, and if we're grounded, then inside of that, if we're hitting the jump button, do jump. Else, set our jump to 0. Or vertical velocity to 0. Here, else, if we are not grounded, then anim.set bool, what is it called? Jumping, I think it was. Set it to true. Let's see. What was it called? Jumping. And actually, if we are currently grounded, make sure that our jumping is set to false. So let's hit play again. Go to our scene view. Find our character. Jump. There we are. So when we jump, we go into that sort of pose. There's a few other issues going on here that we'll have to mention in just a moment. But that's good. And if we look at the animator component, and if I run, you can see it transitions and then starts the run animation, transitions back, runs, jump, transitions to that, and then it does transition to the right one based on the speed. So the only problem is, if we're looking, the jump animation actually moves us quite high. The actual animation. So if we look at just our collider box, the jump is working the way it is, but the actual jump isn't lined up where we would want it. And that's because of the whole, well, it's set up kind of for mechanism. But if we go back into the character, I think what we want to do is we want to bake in all the positional stuff. In fact, we can even bake in the loop say. I think that might actually help. Oops, wrong animation. I want the jumping one. Oh, we did bake in all of that. What about this one? It's still high up, huh? Guess we can offset it. So let me try offsetting it to 2. I'm almost undoing some of what you ideally want to have happen in a system where you're using the actual animations. Grab the player, here, jump, there we are. Yeah, it is a little too low. Although, it's not necessarily too bad. But I want his feet to be just inside the jump capsule. Well, it also does identify another problem here. Let's go to jumping. So yeah, I guess because it's in the ground, it's not what we want, so there. Just above the ground. So that means his feet will be at the bottom of the capsule. But you have noticed, probably, if you've been paying attention in that jump, while our guy sort of goes into a crunch move, was I actually playing with the right animation? I think so. While our guy actually goes into a crunch sort of shape while he's jumping, the capsule does not change height, which means that visually it would look like he might be able to... I had a temporary pop-up there for a second. I don't know what was popping up at me. While it looks like he might be able to jump through kind of a narrow window, for example, he would actually bump the top of his capsule just as if he was standing up, which is not ideal. So what do we do to resolve that? What we have to do is change the height of his Capsule Collider. Right, so Capsule Collider. Whoa. Hey, speaking of shooters, Battlefield 4 just finished downloading. It was on sale today. It's the American Thanksgiving today, and while I'm Canadian, I'm still allowed to participate in all the sales. So, Capsule Collider, because this has a collider shortcut already on it, but it's a generic collider type, and we know for a fact we have a Capsule Collider. So what I can actually do is I can cast the collider like this, or I could also do a get component, but I think this would work just fine. I don't believe this is going to give me an error, or is it? Maybe if I remembered my semicolon. Good. Except I spelled it wrong. Collider. Collider. So when I'm jumping, what I probably... And there's different ways of doing this. Again, the mechanism tutorial has sort of more complex ways of doing this. We're going to cheat. We're just going to say, listen, while we're jumping, set our Capsule Collider height to be equal to, I don't know, let's say 1.2 meters. We're pretty crunched up, 1.2 meters. And what we're going to do is also save it. Float real Capsule Collider height is equal to 2f, and maybe we should have an actual variable here to hold on. Yeah, I guess, you know what? Never hard code in anything. Jump capsule collider height, we'll call 1.2f. And we'll put that in here. And when we are not jumping, we're going to set it back to the full height, which is going to be the real one, like so. So it should actually change from one to the other. And note, this does not happen just when we're jumping. It's anytime we're not on the ground. So when we throw ourselves off an edge, it'll also go into that jumping sort of crunchy pose, which is good, which is what we want. And it'll also change the capsule collider height. Now, the upshot of all this is that our animation, jump down animation, jumping here, because when we change the height, it doesn't actually change the, it doesn't just shrink it down. It shrinks it sort of from both sides at the same time. So really, we're going to want to set this offset maybe to just something like 1. I think 1 might be slightly more accurate given the new capsule size. Let's see, we're going to have to eyeball it. And I mean, doing things visually like this might not technically be the most precise. It's going to be fine for our purposes. And you'd be surprised how many things are just sort of like eyeballed. Do I not have a character? Did my entire Unity just crash and hang? Oh, no, that's always a good sign. I believe this can happen if you're changing capsule sizes, actually, while it's in the middle of a collision. And I suspect that may be what happened. I'm going to put a cut in here, and next time we will try to fix that. See you next time, folks. Bye-bye.